Today we'll do zinc polycarboxylate cement. It was the first cement system which was produced with the potential of adhering to the tooth structure. So it was the first cement system that was developed with potential to adhere the tooth structure. What are the applications? It is used primarily for luting purposes, of permanent restorations, liners and bases, for cementing orthodontic bands, used as root canal fillings in endodontics. Now coming on to the important part, the composition. It is supplied in powder and liquid. It has ZNO, MgO, oxides of bismuth, aluminium. It has also tin fluoride. Over here it has similar liquid as the GIC, that is polyacrylic acid. Then it has copolymer, which has itaconic acid, malic acid and tricarboxylic acid. Okay, now manufactured, it is centered at the powder is centered at high temperatures of around 1100 to 1500 degrees Celsius. The setting reaction, which is important, is when the powder and liquid is mixed, the surface of powder is attacked by acid, which releases zinc, magnesium, tin. These ions, they bind to polymer chain of carboxyl group. They react with it and form cross-linked salts. Now the structure of said cement is very hardened and it has a matrix of zinc polyacrylate with unreacted particles that are dispersed into the matrix. Now coming on to the properties, the main part, why was this acid and what is the difference between the properties. So the compressive strength is inferior to that of zinc phosphate. Compressive strength inferior to zinc phosphate cement. Then it absorbs water, so it is very soluble, absorbs water and is more soluble than zinc phosphate more soluble. Then coming on to the mild pulpal response, it is opaque, so less aesthetic. And one of the disadvantages is that the fluoride release is very limited, so it does not have much of an anti-carcinogenic property. And then there is good thermal insulator. It is a good thermal insulator. In the manipulation part, it is quite similar to that of zinc phosphate, even GIC. What we do is we first condition the tooth surface by tooth structures that are cleaned by 10% of polyacrylic acid, or we can use 37% of the phosphoric acid. I'll just write it. Manipulation First is conditioning, which is basically etching the tooth surface with 37% H3PO4, that is phosphoric acid, or you can use 10% of polyacrylic acid. Then you rinse it with water and the tooth is isolated and dried. Okay, then proportioning, how much is the powder and liquid part. 1.5 parts of powder is to be mixed into 1 part of liquid by volume. First of all, in the procedure, they're taken upon a cold glass slab, and then the liquid is dispersed, and then powder is added with increments in quite bulk, 90%. Then it is mixed using a cement spatula. The cement spatula is quite stiff. The mixing time is 30 to 40 seconds. Setting time is 7 to 9 minutes. Now, as we discussed earlier, that this cement has a property of adhering, so this also adheres to the spatula, the instruments, so it is removed using alcohol. Now the advantages and the disadvantages. In advantages, what we see is that it is less irritating to the pulp and adheres to the tooth structure. In disadvantages, they are that it has a limited fluoride release as compared to GIC, due to which it does not have much of an anti-karyogenic property. Anti-karyogenic.